NH3, which is ammonia, CH4, which is methane, HCl, hydrogen chloride, and then potassium chloride or potassium trichloride, if you prefer. These are just some common examples. Obviously, there are millions and millions of covalent compounds. So, on the other hand, common examples of ionic compounds are things like salt, table salt, NaCl, potassium iodide, potassium bromide, magnesium oxide, and calcium chloride. So what distinguishes these two things from one another? Why are we at such pains to make sure you understand that these are two different creatures? Well, it's the nature of the chemical bond that distinguishes molecular from ionic. And any chemical bond that is formed between any two elements is based in how electrons are shared. So this is a bond between two carbon atoms. This is a bond between sodium and chloride. Electrons are involved, but it's different for the covalent versus the ionic. How is it different? Well, as I just said, any chemical bond is based in the behavior of the electrons joining the atoms together. But in the covalent bond, electrons are shared. So that's these little red dots here. And in the ionic bond, electrons are actually transferred from one atom to the other. So that's very different, right? Sharing versus transferring are two different things. So let me just repeat that. Covalent bonds formed when electrons are shared between atoms. Ionic bonds formed when electrons are transferred between atoms. Now, you may feel like, well, she hasn't even told us what an ion is yet. You're going to know very soon, trust me, but it has to do exactly with this. It has to do with one element losing an electron and another element gaining an electron. That's like the very definition of an ion. So one thing that's extremely useful to know that I'm going to repeat later is that ionic compounds tend to form when metals join with nonmetals. And we just saw earlier today that metals are on what side of the periodic table? Left or right? Left. And non-metals are on the right. So Na is a metal, it's on the left side of the periodic table. Cl is a non-metal, it's on the right side of the periodic table. That's when we get ionic compounds. Covalent compounds, on the other hand, happen when non-metals join together. So things on the right side of the periodic table. Okay. So now that we've established what the difference between a covalently bonded compound and an ionic compound is, let's look at how ions are formed in the first place. So an ion, by definition, is a charged molecule. And the first one that we want to look at is the monoatomic ion, which is very common. So we call it a cation if it has a positive charge. So if a neutral atom like sodium, and by definition, we said with a neutral atom, protons equals electrons. If sodium gives up one of those electrons, it will become a positively charged ion, right? Because it lost an electron. An anion, on the other hand, is an ion with a negative charge. So this happens when a neutral atom, let's say chlorine, gains one or more electrons to become negatively charged. This happens. Negative charge, right? Some atoms, depending on where they are located in the periodic table, like to lose electrons, and others, depending on where they are located in the periodic table, like to gain electrons. Notice that in giving up an electron and forming the sodium ion, it can donate its electron to chlorine. And we get a bond, an ionic bond between sodium and chlorine. So by definition, ionic compounds form when oppositely charged ions come together. The electrons are transferred, and the opposite charges of the sodium and the chlorine, for example, hold the molecules together. So this electron has gone from here, it's gone to over here. The positive and the negative hold these two atoms together. Overall, however, and this is a crucial point, a molecule like sodium chloride has no net charge. Na plus, Cl minus, the charges cancel each other out. So here we see this again in a visual. This little red electron has departed sodium. It's gone over to chlorine. The ionic bond is therefore formed in this process, different from the covalent bond where electrons are shared. So a monoatomic ion or a monatomic ion by definition is a single single atom. But notice we started out with this very simple case of Na plus Cl minus. There is the potential for variable amounts of charge. And these variable charge states depend on how many electrons have been gained or how many electrons have been lost. So clearly, oxygen must have gained 2 electrons because it has a charge of -2. I mean, gained. This one must have lost 2 electrons because it's positively charged, and so on and so forth. Polyatomic ions contain more than one atom. These ones are going to be a lot trickier for you. The polyatomics are going to be a lot trickier for you than the monoatomics. By definition, they're more complicated molecules. They have, you're going to have to learn their names. You're going to have to learn their charge states. This is going to be, learning about these is going to be a memorization exercise. So just know that. Know that you're going to be, and I'm going to show you a table. There's a table of the ones that you must memorize in this slide deck. Just, you have been warned. So you might be asking yourself, I mean, it's kind of easy to see that some neutral molecule of sodium loses 1 electron, goes off into outer space here, or joins a chlorine molecule. That's pretty easy to see, right? Why does something like OH have a negative charge? It's not as easy to see how an electron might have been gained here to give this a negative charge. And you're not really going to understand this well until later in the course when we start talking about something called Lewis structures. So you're just going to have to take it on faith that certain polyatomic ions have certain charges, and you're going to have to memorize them. Another thing that's tricky about polyatomic ions is that they actually have both covalent and they have covalent bonds, but they are still considered to be an ion because they have an overall net charge. So all these bonds that you see right here, I just drew sort of a rudimentary structure here, that are holding the nitrogen and the hydrogens together are actually covalent bonds based in what? What are covalent bonds based in? I'm looking at a couple of questions here. Why does transferring an electron, thank you, Michaela. Why does transferring an electron bind the two together? Abraham, I think you can answer your own question. or someone else can answer it besides me. What binds Na plus and Cl minus together? I'm sure somebody here, the opposing charges. Positive attracts negative. So once that electron has been transferred, there will be an ionic bond. You might be asking yourself the same thing about covalent, and we'll get into that in a little more detail. I'm just introducing you to the covalent bond concept now. We're going to get into it in more detail. But going back to this, so what I want you to take away here is that a polyatomic ion has an overall net charge, but it has covalent bonding within the molecule itself. So OH, for example, has a covalent bond between oxygen and hydrogen, but an overall negative charge of -1. Okay, so that's polyatomic and that's monoatomic. Easier, harder, requires memorization for now. Okay. So that's just an introduction to ionic compounds. I go back and forth here in these slides. We're sort of bouncing back and forth a little bit between ionic and covalent, which is fine because I want you to be able to compare the two and understand the differences. So back to common examples of covalently bonded molecules. We have 4 here. We want to be able to visualize these molecules, how the atoms are joined together, how they occupy space on some level, and where the bonds are exactly. So these are the bonds. These little white lines are our bonds that are the chemical forces that are holding these molecules together based on the sharing of electrons. So we further need to make a few distinctions. We have something called the diatomic molecule, and that's always going to have only 2 atoms, diatomic. This is quite common, but it's very far from the whole story. Things like H2, N2, O2, Br2 are the same 2 atoms of the same element joined together, whereas sometimes you have 1 hydrogen and 1 chlorine, for example, or 1 carbon and 1 oxygen. Polyatomic molecule, not an ion, right? Polyatomic molecule contains more than 2 atoms. Things like O3, ozone, H2O, water, NH3, ammonia, CH4, methane. And we have examples of both diatomic molecules and polyatomics up here. This one, we only have 1 diatomic, right, H2, and the rest are polyatomic. So how do we represent these things in chemistry? Well, we've already seen formulas, right? These are formulas that represent our compounds. We also have structural formulas, and we'll be dealing with those in more detail later on. We have ball and stick models, and we have space-filling molecules. For now, we're definitely going to be focused on molecular formulas, but as the course goes forward, we'll be considering the structural formulas in a lot more detail. Okay, sadly, it is 12:21, but we've made some great progress today. So, any questions before we call it a day? Oh, memorization. You know what? I'll just show you that quickly. If you want to work ahead, the polyatomic ions